Okay, there's been a few requests for kind of an overview of how I make some of the parts that I make with my CNC wood router, how you go from the design phase to an actual completed part. So in this video I'm going to attempt to explain that process, give a little summary. I'm not going to get into the nuts and bolts too much of the some of the software, but just kind of an overview. So for this example, we're looking at making some servo supports for the Revolver 70 airplane. In the tail of the aircraft you can see there's an open bay, no place to install a servo, so we need to put some supporting structure in place there. So the basic idea is we're going to make a plate as shown here in this next picture. A plate, kind of a D-shaped plate that has the servo cutout, and in order to make it sit flush with the surface, in this next picture we're going to make like a slightly oversized frame around it, and once that is glued to the back of the first piece, we're going to have a nice little assembly here as shown in this picture. It has a little lip around the edge so that once inserted into the airplane it will look like this here on the last frame. So in order to do that, I took some basic measurements with my calipers and determined that the width from top to bottom is about 74 millimeters, and kind of chose a arbitrary length of 94 millimeters. And of course the standard servo holes are 20 millimeters by 40 millimeters, and I'm making them slightly oversized so that you got room to put the the wires in, that sort of thing. And I'm also going to produce, unlike the pictures here, I'm actually going to have the machine make pilot holes as well. So in the next little segment we'll go into the actual designing those parts in the CAD program. Okay, I've started my CAD program, Rhinoceros, that I prefer to use, comfortable with. I'm going to select a project of millimeters, since a lot of my measurements were taken in millimeters off of the airplane, and servos or servo holes and things like that, so kind of arbitrary. But anyway, so I'll start by making just my simple rectangle here, and we said it's going to be 94 by 74 millimeters. Need to do a fillet on one of these corners over here. I'm going to make a radius of 0.5 inches. Nice thing about Rhino is you can specify units on the fly. So there's one radius. I'll do it again. Okay, there's our lines. Now I need to do an offset of these lines right here. So I'll select those, join them together, and then do an offset command. My distance is going to be 1/8 of an inch on the outside, and then do it again on the inside. And this will be my outside piece here. So select those, and then I'll just go ahead and move them out of the way. Just put them over there. Okay, now I need to finish this end off here. So draw from there to there. And this line right here, I'm going to also do an offset on of 0.25 inches. Like that. Now I've got just do a little cleaning up of these little interior corners, and then make that one whole piece. Okay, so there's our pieces. So you can see once this is in place over here, it'll have a nice little gap all the way around there. Okay, now I need to add my servo holes, so I'll kind of zoom in here a little bit, and let's go about right there. So we said I'm going to make them 42 by 20.5. That'll give a little extra clearance for shoving the wires in, that sort of thing. Kind of a trial and error thing, but that should work fine. And just to be slick, I'm going to add some holes pre-drilled holes for the servo. I know that it's 3.5 millimeters away from the case this way, and if I go up this way 5 millimeters, that's where the center of the hole is, and that was just by measuring a servo. And so I will add a circle there. Oops, that didn't take. Let's try this again. I want 0.0625 inches. There we go. There's my hole. And now I'm going to do, it's called a mirror operation. This is where the beauty of CAD comes in. I can just copy that, select it over there, mirror it over there, and then I will mirror this again around the midpoint of the servo. And now my holes are there. Delete that little construction line, and here we have it. I wanted to make a left and a right piece, basically two sets, so I'm going to do it all in one machining operation, so I'm just going to make a copy of these and just put them right down here, like that. Okay, so that is my drawing. I'm going to go ahead and save this right now. Call it servo mount. Yes. Okay, now before I export it, I'm going to actually change the units to inches because my CAD program tends to be happier with that, and the actual software that my CNC machine is running, called Linux CNC, all the units are in inches, so before I get too far down I will do that. So it looks like it kind of shrank everything, but in reality it just changed the units. I could double check by tell it I want to dimension, say between a couple of points and 3.7 inches. Yep, that is correct. Okay, so that's good. So I'll highlight those pieces, and now I will export these particular lines into a format that is usable by my CAM program, namely DXF. So I'll call that servo mount. Save, yes. Save. Okay, so now the parts, the lines are saved, and next I will open them up into my CAM program. Okay, next I've started my CAM, stands for Computer-Aided Manufacturing Programming. CAM-BAM, kind of a fairly economical program that works well for my uses. So anyway, open up my file that I just made. Servo mount DXF file. And there's the files. I'm going to highlight all the pieces and join them all together so that they're continuous loops as opposed to a bunch of disjoint lines. And basically now we need to tell the software kind of what kind of machining operations we want to do on these shapes. So the first thing I'm going to do is I'm going to highlight all these circles right here and tell it I want to do a drill operation. And I've got some kind of preset styles for different types of wood. I'm just going to use this one. Notice this is clearance plane 0.125. That tells the bit how high above the surface it needs to be before it moves someplace. Target depth minus 0.14, that's relative to the top of the piece of wood, so I'm using 1/8 of an inch plywood, and if I scroll down here I'm using a 1/16 inch diameter bit end mill. So there's a bunch of parameters in here that do all kinds of things. One of the things I'm doing, I need to change here, make this what they call a canned cycle. It just means the bit's going to go up and down and not do like a spiral milling operation. So that's the first one. So it's going to drill those holes first. The next thing I want to do is do what's called a profile operation to cut these interior holes of these parts. So I will select profile and then choose my style once again, which is ply cutout. This has some parameters that are useful, like my cut feed radius 30 inches per minute. The depth increment is 0.08, so it's going to do 2 passes to get down to the 1/8 of an inch depth, just because I'm using a very small bit, and if you push it too fast it could possibly snap. And if we look at the profile, we notice it says inside. So that means the bit's going to go kind of follow around on the inside of this line so that the outside of the bit is actually on the line. Okay, so that's my second one. Then the last profile we need to do is these exterior pieces. And we're going to do another profile operation there. And this time I'm going to choose a style called ply cutout with tabs. And what this does is it makes what they call building tabs. So I'm going to tell it to generate the tool paths. And notice what it has done here. If I zoom in here, you can see this light blue line. That's the inside of the servo. So that's the tool path that is going to go on the inside. On the outside, you can see it's going to go around the lines. The green line represents it's doing an arc move as opposed to a straight line. Then it's going to put these at these locations here. It's going to make what they call building tabs. I can actually change the view here to a, see, like if I look at it from the side, you can see that that's what the tabs are going to look like on the side. These are you can see the two different layers of cutting. These moves up, these lines up here are where the tool head is actually going to move. So we'll switch back to my XY here. And that's it. You can see the little arrows. It just basically shows how the bit's going to move around. And it does a good job of that. And so once that is done, I will tell it to produce G code. And I'm going to call it servo mount. And it makes what's called an NGC file, which stands for G code. And then I'll save this file itself. Say yes. And that's all there is to it. And what I do is I take this file, I send it to my server that I can then access from the computer in the garage, actually running a machine. But before I do that, I'll just take a look and I'll just open the G code and show you what this G code looks like. These are all commands that the computer running the actual machine recognizes. For instance, this is drill one operation. This G0 right here, for instance, stands for a rapid move to this XY coordinate. And then there's the drilling operations. And for the profile operations, it does a few rapid moves to position the bit. And then there's a G1 move, and it has a feed rate of 10 inches per minute, which is my, it drops down to a certain height. Then using a feed rate of 30 inches per minute, it goes to these various XY coordinates to produce the profiles. So you may have seen, certain programs on the TV. I see CNC machines in the background. A lot of times you'll see this stuff scrolling down on the screens while it's running. But that's the G code. Okay, so that's pretty much all there is to it. Next, we'll go out to the actual machine and fire it up. Okay, here's a little walkthrough of what my CNC machine looks like. It's a basic form. It's called a Gantry style, referring to this gantry right here. It runs on aluminum guide rails from end to end. It's a chain drive through sprockets. So the ZAxis is considered along the table. The Y-axis runs left and right across the gantry, and then the Z-axis goes up and down. The Z-axis motor runs this lead screw right here through a anti-backlash nut, and that gets your vertical motion using a standard router, wood router, that is adequate for the job. Go around to the back of the machine here. You can see there's one of the stepper motors that runs the chain drive for the axis left and right. And there's a motor here that runs the X-axis through a series of pulleys here. All of this is made out of a material called MDO, medium density overlay, which is a kind of a marine grade plywood used for making signs. It actually has a structural strength similar to about 1/4 inch aluminum plate. All of the bearings, I'll try and zoom in on one here, used in the machine are what we call V bearings. Kind of like skateboard bearings, except they've got a little V in the notch here. And they pinch the aluminum rails, and that gives you your strength, and yet is also very smooth. The board structure that the machine is assembled on is called a spoil board. It's kind of like a sacrificial piece of MDF because you drive screws into it and attach fixtures to it. You can see here I've got 2 pieces of wood ready to go that have been screwed onto the plate. I've discovered that if I'm using balsa wood making ribs, I can just use 3M 77 spray adhesive and just spray them to a piece of foam, and the balsa wood will stick to the foam with enough strength that I can just cut directly onto that and then just peel the parts off. So that's just kind of one other aspect of how to things you got to deal with holding the work surface material down. On the head itself, I've got a kind of a dust collector here held on magnetically. You can see there's the business end of the router, and I've got a vacuum system. The dust head just kind of helps contain some of the dust, yet is flexible enough so that it does not interfere with the operation of the router. This might be kind of hard to see, but I'll do my best here. This is a Linux-based system. I've got a program called FileZilla, which I can use to do FTP, file transfer protocol, to my server. And so what I'm doing is I'm pulling up my file here. To upload to this machine. Now I'll go ahead and launch my Linux CNC program. First thing I need to do with setting up the machine is the machine is kind of parked in a home position, so where all of the axes are in one corner at the physical limits of it. So that is a home position. So I'm going to home all of the axes, and then I'm going to open up my file. Go ahead and rotate it around. Okay, there we go. If we zoom in on it, notice you can kind of see in 3 dimensions here. This is showing what the tool head is going to do. You can see the little blue lines is going to drive across, do these drill operations, and make 2 passes. Where it's going to jump up and do the tool paths for the building tabs. It gives the dimensions of the piece of wood that I'm going to need, roughly an 8-inch by 6-inch piece, which I think is long enough here. Let me double check. Yeah, let's see here. 6.5. Yeah, that'll work. Okay, decided to change out my piece of wood and go with a larger piece. Instead, the other pieces were just a hair too short, so I just grabbed a bigger piece of wood. And now looking at the screen here, I'll show you. The screen is minus 3 inches to 3 inches on the y-axis, and it's showing 0 to like 8 on the x across the bottom. So basically what I need to do now is basically tell the machine where the lower left corner of my work surface is. So for that, I'm going to go ahead and put the camera back on a tripod here so I can move. So be right back. Okay, now we're back. So basically what I need to do is tell the router where it is in space here. So using my my handy little PlayStation jog pendant here, I'm going to run the bit down. And just kind of get it down about where I want the lower left corner of the work surface to be. And then in the computer software, I just tell it, do what they call a touch off. I'm not going to go ahead and do it. Basically, I just tell the program, okay, this is my new X0, and my Y, this is now minus 3 inches on the Y-axis. And then the last thing I need to do is tell the machine where the wood is relative to where the head is, the drill bit is relative to the work surface. So I use this very high-tech method of using a piece of paper, drive it down until it just grabs the paper, so I know, okay, that is 0. So now I'll tell the computer, okay, that is my new 0 position. And I'll go ahead and run the head up. Okay, and that's it. Now the program is ready to go, and all I have to do is tell it to start cutting. Before I do that, I'm going to go ahead and put my dust head back up here. That helps get rid of all the shavings and stuff. Alright, time to... away we go. run the head up here. Just for fun here, I'm going to back the machine up here, and I'm just going to kind of show you how the machine can operate, how fast it can go. Alright, got the machine parked, and like I said, we've got the holding tabs on here, so all I have to do is just kind of like a sprue on a model airplane. Depending on how, anyways, there's our parts. So you can see basically how the parts go. The part just like so. Alright, so I'll just go ahead and trim these up and just a little bit of light finish sanding, and we're done.